All right. Here we go. Remember that you can ask questions on homework in the forum. And I encourage you to do so that we can get things done expeditiously. We're going to be talking about integer and rational number exponents today. This is section 2. I do intend that you should know the properties of real numbers. They're on page 11. If you have a question about any of those, then by all means, I'll give you time to ask. And of course, we'll want to make sure that everybody's up to speed on absolute value. But let's just talk about the definition of exponent. So, definition of exponent. And just remember, things do what they do because they are what they are. Okay? And so when we talk about this, when I say a to the nth power, I am talking about the product of n factors of a. So you can see that this is a product statement here. So this is the product of n factors of a. In other words, we know that multiplication is repeated what? Multiplication is repeated addition. And so exponent is repeated what? Multiplication. That's what it is. Okay? So, let's just take an example of this and see if we can derive some properties of exponents by looking at just the definition. Okay? And so you can see that a to the 12th power is a times a times a, and 5, 6, 7, 8, 9, 10, 11, and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay then. So, if I do this and I do this, okay, what's this? A to the 4th, okay. What's this? A to the 8th. That's A to the 12th, isn't it? Okay. So let's see, we're going to put up our work here. A to the 4th times A to the 8th is A to the 12th. And so now we're going to try it a bit differently here. And let's see, how about that? That's what? A to the 7th times A to the 5th is A to the 12th. Okay. How about that? A to the 2nd times A to the 10th is A to the 12th. Now tell me, what do you see here if I am multiplying exponents here? Now remember this, the A is the base, okay? And up here, exponent or the power. So what's happening when I do this? I'm adding the exponents, okay? Because the number there tells me how many A's I have as a product, right? How many A's I have as a product. So I can write this up as a general statement, okay? A to the m times a to the n is?
A to the m plus n.
What does it say? What are you doing?
A to the m plus n.
Now, one of the things you don't want to do is fall into the trap of just trying to remember what you have memorized. A lot of you have memorized things wrongly. Okay? I'm trying to show you a way of understanding it so that you don't ever forget what the rules are, because you can always recreate them. Maybe you see what we did there? We actually created rules, didn't we? Okay, have any of you ever created your own rules? Ever done it in math? Okay. So there we've got this. Okay, so let's try another thing here. And so let's see. Okay, let's see, what do we have here? A to the third, a to the third, a to the third. So we have 4 factors of a to the third, right? Okay, so this is a to the third, and I've got 4 factors of that, right? So that is a to the 12th, okay? All right, so let's try it a little differently here. So what do you see there?
A squared
To the 6th.
Right, raised to the 6th power is a to the 12th. Okay. And of course, bless you.
Thank you.
Of course, now when I sneeze, they have to check the room for structural damage. So this is
a to the 6 raised to the 2nd power.
6. So that would be a to the 6 to the squared, or to the 2nd power. Okay, that's also a to the 12th. What do you see there if I take an exponent here, all right, and I raise this group to that power? In other words, I multiply repeated groupings, right? What do I do then?
Multiply the exponents.
Okay, so let's see. How would I write the rule here?
A to the
m
to the nth power.
to the nth power.
A to the mn.
A to the m times n. Okay, now do you see? The rule here makes sense because you're seeing that everything follows from what?
Example.
The definition, right? Yeah, it is an example. We're using an example, okay? But you see, this was the definition of a to the 12th, right? And so, in doing something like this, we're able to get some very, very good ideas. Now, everything follows from the definition. It does what it does because it is what it is. Now, you'll notice that we have this situation here, okay? So what would happen then if I talk about a to the 4th times a to the 3rd? That would be a to the 7th, because I have 4 factors of a here and 3 factors of a there. What would happen if I did a to the 4th times a to the 0?
A to the 4th.
a to the 4th. That's interesting. What would happen if I had a to the 9th times a to the 0? A to the 9th, okay? Now, instead of putting that in, suppose I had a to the 4th times something is a to the 4th. What would you naturally think ought to go in there?
It's got to be raised to 0.
But, okay, if you're not putting in an exponent, what would you
1.
put? Say it.
1.
1. Why?
Because any exponent to 0.
Well, now that's true, but we're trying to prove why. Okay, so what do you know about multiplying by 1?
Anything that's
It gets itself.
Right, okay. 1 is known as the multiplicative what? Identity, right. Okay. Now you can see that this is the same as this, okay? And since products are unique, okay, they are, then this has to be the same as that. So what have we just demonstrated?
The A to 0.
A to the 0 is 1. Okay. No need just to accept the rule as stated. Well, now let's see here. So let's see. A to the 4th times A to the 3rd is A to the 7th. And I can use a definition of division. Okay. And the definition of division goes like this. A divided by B is equal to C if B times C is equal to A. We know that division is the inverse operation of multiplication, right? Okay. So if I'm going to do this, then let's try it with this thing right here. So I know that A to the 4th times A to the 3rd is A to the 7th. So how can I write that as a division statement? Yeah, A to the 7th divided by A to the 3rd is A to the 4th. Okay. Question?
No.
Okay. If you have it, ask by all means. All right. So let's see. Suppose I have A to the 19th divided by A to the 7th, and that would be A to the 12th. Why?
Because you subtract the exponents.
Okay, but why do I subtract the exponents?
Because it's the inverse of multiplication.
It's the inverse of multiplication, but again, remember that by our definition of division, okay, now we've already proven this rule, haven't we? Okay, so I could rewrite this as A to the 7th times A to the 12th, and I would get A to the 19th. Now these two statements are equivalent. Okay? They're expressing the same kind of relationship. Okay? One's just the inverse of the other. And so you can see that I can have confidence then in this being a subtraction process. If I want to work with this as a rule type of idea, let's see what we would have. If A to the m divided by A to the n is, well, let's just say A to the x for the moment. Okay? And so that would mean that A to the n times A to the x is A to the what? M, which means that n plus x is, so n plus x is m. If I want to solve it for x, what would I do? Subtract the n, right? So x is m minus n, right? Okay, and so I can go here and replace, and I've created a new rule from an old rule, right? Using the definition of division.